Hello, I'm Donald Fuller, and I will provide you a short briefing on Open System Interconnection Reference Model. The Open System Interconnection Reference Model, more commonly known as the OSI Model, was developed by the International Organization for Standardization as a model for a computer protocol architecture and as a framework for developing protocol standards. The OSI was developed as part of the Open Systems Interconnection Initiative. In its most basic form, it divides network architectures into 7 layers, which from top to bottom are the application layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical layers. I will present a brief explanation of each layer, starting with the application layer. The 7th layer is the application layer. It is the OSI layer closest to the end user. This layer interacts with software applications that implement a communicating component. Application layer functions typically include identifying communication partners, determining resource availability, and synchronizing communications. When identifying communication partners, the application layer determines the identity and availability of communication partners for an application with data to transmit. Some examples of the application layer implementations include the Hypertext Transfer Protocol, File Transfer Protocol, and the Simple Mail Transfer Protocol. The 6th layer is the presentation layer. It establishes a context between application layer entities. This layer provides independence from differences in data representation by translating from application to network format and vice versa. The presentation layer works to transform data into the form that the application layer can accept. This layer formats and encrypts data to be sent across a network, providing freedom from compatibility problems. It is sometimes called the syntax layer. The 5th layer is the session layer. It controls the connections between computers. It establishes, manages, and terminates the connection between the local and remote application. It provides for full duplex, half duplex, and simplex operations and establishes checkpointing, terminating, and restart procedures. The OSI model made this layer responsible for graceful close of sessions, which is a property of the Transmission Control Protocol. Also for session checkpointing and recovery. The session layer is commonly implemented explicitly in application environments that use remote procedure calls. The 4th layer is the transport layer. It provides transparent transfer of data between end users, providing reliable data transfer services to the upper layers. The transport layer controls the reliability of a given link through flow control, segmentation, desegmentation, and error control. Some protocols are state and connection oriented. This means that the transport layer can keep track of segments and retransmit those that fail. Examples are Transmission Control Protocol and User Datagram protocols. The 3rd layer is the network layer. It provides the functional and procedural means for transferring variable link data sequences from a source to a destination via one or more networks while maintaining the quality of service requested by the transport layer. The network layer performs network routing functions, fragmentations, reassembly, and report delivery errors. Routers operate at this layer, sending data throughout the extended network, making the internet possible. The best known example of a network protocol is the Internet Protocol IP. It manages the connectionless transfer of data from one hop at a time. It is not responsible for reliable delivery to the next hop, but only for the detection of error packets so they may be discarded. When the medium of the next hop cannot accept a packet in its current length, IP is responsible for fragmenting the packet into significantly smaller packets that the medium can accept. The 2nd layer is the data link layer. It provides the functional and procedural measures to transfer data between network entities and to detect and possibly correct errors that may occur in the physical layer. Only error detection, not flow control using sliding windows, is presented in modern data link protocols such as point-to-point protocol and on local area networks. The IEEE 802.2 LLC layer is not used for most protocols on Ethernet, and on other local area networks, its flow controls and acknowledgement mechanisms are rarely used. The first layer is the physical layer. It defines the electrical and physical specification for devices. In particular, it defines the relationship between the device and the physical medium. This includes the layout of pins, hubs, repeaters, network adapters, and more. The physical layer is concerned primarily with the interaction of a single device with the medium. The physical layer will tell one device how to transmit to the medium and another device how to receive from it. Such standards are RS-232 do not use wires to physically control access to the medium. The major functions and services performed by the physical layer are establishment and termination of a connection to a communication medium. In summary, OSI was detected as part of the Open System Interconnection Initiative. It divides the network architecture into 7 layers, and they are application layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical layer. Thank you for listening.